In this lesson, we are going to continue our discussion on the angle addition postulate in angle bisectors. But there are some times when I can tell you things about angles without actually saying something about the angles. Sometimes you can know what the angles add up to be, what the whole piece is, without me actually saying. And those are when we have different combinations of rays and angles. So the first one, and if you need to pause this at any time, if you're taking notes along with me, then you can just pause it until you're caught up. But complementary angles shouldn't be a new word. They are two angles that add together to be 90 degrees. Now, they can be adjacent or they cannot be adjacent. Remember that to be adjacent means side by side. So this is an example of what they look like if they are adjacent. This is what they look like if they are not adjacent. All they have to do, all it takes to be complementary is to add to 90 degrees. Now, supplementary angles are angles that add to 180 degrees. Again, same as complementary angles, they don't have to be adjacent. So you can have these right here, they are adjacent and supplementary, and these are supplementary but not adjacent. So they can add to 180 degrees and not be adjacent. So that's the only requirement is that the angles add to 180 degrees. Then we have opposite rays, and I have several examples here. Opposite rays are rays that share a common vertex, but they extend in opposite directions. Now, I want to show you the difference is these angles right here, or these rays right here, they share a common vertex, but AB and AC both go the same direction. AB starts here at A, goes towards B, and continues going forever. And then AC starts here at A and goes towards C and keeps going forever. So those share a common vertex, but they go in the same direction. These share a common vertex, these at B, these share a common vertex, B to A and ray BC, but they just go in different directions. They don't go in opposite directions. They don't go in the same direction. They just go in different directions and they form an angle. So what I mean by opposite rays and that they go in opposite directions would be this picture right here. BA goes in this direction, it stops, it has an end point at B and extends infinitely in the direction of A, and then BC starts at B and goes infinitely in the direction of C. Notice that those opposite rays also help form this straight angle that we talked about yesterday or the other day. Okay, then we have a linear pair. Linear pair and vertical angles, which we're going to talk about next. Those are two extremely important words. You're going to need to know those, and you're going to need to know them all year long. So make sure that you understand them, you know what they look like, and you recognize them, because a lot of times I'm going to say, what do you know? They equal 180. Why do you know that? Because they're a linear pair. What do you know? They're equal to each other. Why do you know it? Vertical angles. So you need to know those words and these definitions. So a linear pair are adjacent angles, which means they have to touch, they have to be side by side, and they are supplementary. Remember, to be supplementary, all you had to do was add to 180, but to be a linear pair, you have to be both supplementary and adjacent. So linear pairs will always look something like this. Notice that their non-shared side forms opposite rays, okay? And they are always going to, they're supplementary, which means they are going to always add up to be 180 degrees. Okay, notice these two angles here. So we have this angle here and we have this angle here. They are going to add up to 180 degrees. Now, don't be confused, okay? If you have a line, and I'm talking about segments, and it happens to have a segment bisector or a line that bisects it through the midpoint, this is very different. If I say segment AB, that's segment AB and BC. Those are segments. Segments never add up to 180 degrees. Where this one might say A, B, C here, it's going to say angle ABC and angle CBD are a linear pair. So it has to say angles. Angles are linear pairs, but segments are never a linear pair. So don't get confused by that. It's a common mistake. Okay, and then lastly we have vertical angles. Vertical angles are opposite angles. We said adjacent is side by side like your shoulder partner, and opposite is the person who's across from you. So they are opposite angles and they're formed by opposite rays. Okay, now let's see what their relationship is. So if this angle is 50, these two angles right here form this linear pair. So that means their total is 180, which means this angle is 130. Then we have the same thing that happens this way. This is also a linear pair, and that means this angle is also 130 degrees. And then we have this last linear pair. We've got several linear pairs here. If that's 130 degrees and this is a linear pair, then this is 50 degrees. So here's what I want you to see. The vertical angles are the angles that are formed by the opposite rays, and they are opposite angles. So these angle pairs, that angle pair, they are both 50, and they are equal to each other or congruent. And then we have this 130 degree angle and this 130 degree angle. They are opposite each other, and they are vertical, and so that means they are congruent to each other. So the important thing about vertical angles is that they are congruent to each other. Now, just a side note, just to give you an example, they're formed by opposite rays. And so you need to recognize that, like, so these are opposite rays, but this would not be an opposite ray. Okay, so these, if I drew that straight, it doesn't look very straight, but pretend it is. So these are not vertical angles. These are not vertical angles because while they are opposite of each other, they are not congruent because they are not formed by that X that is formed by those opposite rays. Let's look at some sometimes, always, nevers with these. So linear pairs are supplementary. So we know what a linear pair is. A linear pair always looks like this. And by definition, linear pairs are supplementary. I didn't ask about being adjacent, but a linear pair is supplementary, so that is always true. A linear pair will always add up to 180 degrees. Remember that angles are portions of circles, and so that linear pair is half of a circle. That's why it's 180 degrees. Supplementary angles are adjacent. So remember, adjacent means side by side. Supplementary means they add to 180 degrees, but remember, to be supplementary, all they had to do was add to 180 degrees. Whether they were side by side did not matter. So yes, they can be adjacent, but they don't have to be, right? That's what we drew up here. These were adjacent and these were not, but they were both supplementary angles. Okay, linear pairs are adjacent. That is always. They have to be touching each other here to form that straight angle together. So they are both adjacent and supplementary. Remember that we talked, that's the definition, adjacent angles that are supplementary. Vertical angles are adjacent. Well, adjacent means side by side. Vertical angles are opposite, right? Vertical angles are opposite. They are these pieces. They kind of form those back-to-back V's. See, we've got these V's here. So those are vertical. These two are vertical. And so vertical angles are not adjacent. They're never adjacent. They are always opposite of each other. Supplementary angles are linear pairs, this last one. So supplementary angles mean that they add up to 180 degrees. Linear pair means they add up to 180 degrees and they are adjacent. But remember that you can be a supplementary angle without being a linear pair. So sometimes they are linear pairs, but sometimes they are not. So here is an example of when they are not. Maybe this is 110 and this is 70. Those are supplementary, but they are not a linear pair. So they can be, but they don't have to be. Okay, that's how your sometimes, always, and never work. So if I want to use the diagram at the right to name a pair of each of the following, you have multiple answers. So adjacent simply means that they are side by side. So I could say that angle 1 and angle 2 are side by side. They share side XC. And they don't overlap. They have a vertex at X. I could say angle 2 and angle CXE or angle 5. Remember that you can name them by their angles by their full name, or you can name them by their nickname. Angle 1, angle 2, angle 5, angle 6, angle 3. Those are some examples of adjacent angles. Here is, we'll color them in. Those two are adjacent. Vertical angles, you have to be careful here. Make sure you are dealing with your opposite rays. And so we've got one set here, right? We've got our opposite rays where we can form our X. So angle 3 and angle 5 are vertical angles. That is one example. I could also say angle 6, but be careful, it's not angle 6 and angle 1 or angle 6 and angle 2. It would have to be the entire angle. So I would name that AXC. So I could say angle 6 and angle AXC. That's the only way to name that whole big angle. And then a linear pair, what we're looking for is angles that form that straight line. So if they're going to form this straight line, they're right here, right? And there are lots, right? We have this straight line, those form a linear pair, those form a linear pair, those form a linear pair, these form a linear pair. We have lots of options. So angle 3 and angle 6. You've got angle 6 and angle 5. You've got angle 3 and angle AXC, that red angle right here, angle 3 and angle AXC, they form a linear pair. You're just looking for them to be adjacent and have that opposite ray on their non-shared side.
Okay, to get some practice with vertical angles and linear pairs, let's look at number 3. Ray OA bisects angle BOF and angle COE is 160 degrees. Find the measures of the angles. Now, you've got a lot of blanks here, and here's one of the things you want to start doing in this class is not start with the first blank and then the second blank and then the third blank. You won't always process a problem that way. So what you want to do is start with the information that you were given. Ray OA bisects angle BOF. So if we find angle BOF, here it is, ray OA bisects it, which means it cuts that angle in half. That means what that is important to us for is angle 1 is congruent to angle 2. Angle COE, so here is angle COE right here, is in total 160 degrees. All right, so from there, what you want to do is just go with what makes sense to you. Okay, you might see vertical angles first. You might see straight angles with linear pairs. In this case, they're not linear pairs because there are 3 angles, but they still add up to 180 degrees. So you might start with angle 3. You might start by noticing that angle COE and angle BOF are vertical angles because they're formed by these 2 sets of opposite rays. So we do know that angle BOF is also 160 degrees because it's vertical. And then since these 2 angles have been, that whole angle has been bisected, angle 1 is congruent to angle 2. That means that we know that angle 1 is 80 degrees and angle 2 is 80 degrees. That tells us that angle 1 and angle 5 are vertical, so angle 5 is 80 degrees. 2 and 4 are vertical, so they are also 80 degrees. That leaves us with 3 and 6. 3 and 6 are vertical to each other, so they're equal to each other. And then you can use whatever angles you see, but notice this straight angle right here. Angle 1, 2, and 3 form a straight angle, which means they add up to 180 degrees. We already have 160 degrees used up. That leaves us with 20 degrees for angle 3. That also, we have that same line of thinking here with this straight angle on the bottom. Or you can also say that 3 and 6 are vertical, and so we have 20 degrees here. Okay, so angle 1, now we can go fill in our blanks. Angle 1 is 80 degrees, 2 is 80 degrees, 3 is 20 degrees, 4 is 80, 5 is 80, 6 is 20, AOC, angle A to O to C, that's these two angles here. Let me switch colors. AOC is these two here, so that is 100 degrees. EOC, E to O to C, that's these two angles right here, that's 160 degrees. And angle AOD, AOD is this straight angle, it is 180 degrees. It's important to process the picture, let yourself decide how you're going to process. What do you see next? What do you know now? That's what you want to ask yourself. Label what you know and then ask yourself, what else do I know? Going this way is not always going to be the most logical way to process it in this order. Okay, so just keep that in mind as you're working through problems in the future. Number 4 says that angle PSQ and angle QSR are complementary angles. What is the measure of each angle if angle QSR is 7x minus 26 degrees and PSQ is 3x plus 6? Let's label what we know. QSR is this angle here. It is 7x minus 26, and PSQ is 3x plus 6. Now, you look at that. I've mentioned when you see a vocabulary word, you know that you're going to use that vocabulary word. It's there for a reason. So what does complementary mean? Complementary means angles that add to, whose sum is 90 degrees. So while it is not on there, it was not explicitly given, it is understood that these two angles together are 90 degrees. So I do have the whole, even though I was not explicitly told what it was. So we know that these two, the sum of those two, 3x plus 6 plus 7x minus 26 is equal to 90 degrees. From there, combine your like terms and do your algebra. So we have 10x minus 20 is equal to 90. 10x is equal to 110, or x is equal to 11. Notice I didn't ask for that. So be careful on quizzes and tests. Don't just put the answer that you got. I asked for the measure of angle QSR. QSR was 7 times x minus 26. So 7 times 11 minus 26. Find my calculator here. I don't like to do it in my head. 77 minus 26 is 51. So QSR is 51 degrees. Now we know that the sum of those should be 90 degrees. 90 minus 51 is 39 degrees, and we can do a quick check. Angle PSQ would be 3 times 11 plus 6, which is indeed 39, like it should be. Those two do add to 90 degrees like they were described in the problem. Okay, so watch for those vocabulary words. When you get to number 5, notice those vertical angles and linear pairs should be bouncing out already. We have all these linear pairs, and then we have these vertical angles. Now, notice this linear pair here. You could start there, but if you did, you'd have y plus 23 plus 2x minus 17 equals 180. The problem is we have two variables, and we want to avoid that whenever possible. So let's switch over to this one. Now, there's two ways you can think through this problem. 2x minus 17 plus 63 is equal to 180 degrees. Or you could also know that these two are going to add to 180 degrees. You have already used up 63 degrees of it, so this angle has to equal 117. So the question is then, what does x have to be so that that angle can be 117 degrees? So you can do the whole thing, and in the end, you're going to end up in the same spot. If you did 2x minus 17 plus 63 is equal to 180, and then you combine 63 and the negative 17, you get 2x plus 46 is equal to 180. 180 minus 46 is 134. I'm going to stop right there just to show you something. If you did it the other way, where I said 2x minus 17 is equal to 117, if you add 17 to both sides, you get 2x is equal to 134. So see, you will end up in the same place at some point. So that's why it doesn't matter which way. Because this way, you're still doing this math, you're just doing it a little more mentally. Okay, so 134 divided by 2 is 67. So that means that x is 67. Once we know that x is 67, We can use that if we need to find y. We actually don't need to. I know that these are vertical angles. That means that this angle is also 63 degrees. And so what does y have to be so that that angle can be 63? Subtract 23 from both sides and you get that y must be 40 in order for that to be true. Now again, you could use these two and do a linear pair. Now that you know what that is, you could say y plus 23 plus 117 equals 180. You'll get the same answer either way. Okay, so complement and supplement, we spent some time on that. We just did complementary up here. A complement is the angle that makes the given angle become 90 degrees, and the supplement is what makes it equal 180. So a complement is you have a given angle. The complement is what you're going to add to the angle. So if you would take 90 minus 51, then you would get the complement of a 51 degree angle. So the complement of a 51 degree angle is 39 degrees. The supplement of a 51 degree angle is 129 degrees. Okay, so complement and the angle plus the complement are 90 degrees. The angle plus the supplement are 180 degrees. Okay, and those two angles together, the angle and the complement, are complementary. The angle and the supplement are supplementary. Okay, so we have this problem here. An angle is 6 less than twice its complement. Okay, so when we see that complement, what we know, let's just write down what we know. We know that an angle plus its complement equals 90 degrees. So let's start there. Now, I told you that an angle A equals 6 less than twice the complement. We'll call the complement C. Okay, 6 less than twice. Twice means 2 times. So we want to take 2 times the complement and subtract 6 less than. You switch and you subtract it from. If you have $5 less than me, you would take my money and subtract 5. Okay. So this is 6 less than twice its complement. Well, we have 2 variables, but we have a very easy way. We know what A is. So we're just going to take this right here and we're going to substitute it in for A. So if we change the angle is 2 times the complement minus 6. And if I add the complement to that, those two, this angle, right, 2c minus 6 was the angle. The angle plus the complement is 90. But now I have one variable. 3c minus 6 is equal to 90. 3c is equal to 96. And that means that the complement is 32 degrees. So the complement is 32 degrees. So what was the angle? Well, the angle is 90 minus the complement, which means the angle is 58 degrees. Okay, so this right here is the key. Remembering this, in fact, let's go back here. That is what's important. Complementary angles means the angle plus the complement is 90 degrees. So this another one that's similar to that, an angle is 10 more than 1/3 of its supplement. What is the measure of each angle? Remember that an angle plus a supplement add to 180 degrees. So the sum of those two is 180 degrees. We have information. The angle is 10 more than 1/3 of the supplement. Okay, 1/3 of it, or 1/3 times the supplement. So we're going to change this angle into terms of the supplement. 1/3 of the supplement plus the supplement is equal to 180. Remember, this is our angle. We just changed it so that we have all the same variable. All right, so fractions always throw us off. Let's combine our like terms. So we've got our s and our s. Let's make this 3/3 so that we're able to add it to it. We'll subtract 10. So we know that 1/3 plus 3/3 is 4/3. So 4/3 of the supplement is equal to 170. A lot of ways you can think about this. This is divided by 3. The inverse of division is multiplication. Or you can, and then you can divide by 4. So you can multiply by 3, divide by 4, or you can do that all at the same time. We can just multiply by the reciprocal. It will make this fraction cancel out to 1, and we get that the supplement is 170 times 3 divided by 4. Like I said, you could have done that in 2 separate pieces if you wanted to. So the supplement is 127.5. From there, we would say 180 minus the supplement gives us what the original angle was to begin with, which was 52.5. So the angle is 52.5 degrees. The supplement is 127.5. Now, let's go back to just kind of double check this. An angle is 10 more than 1/3 of the supplement. So let's do this. So 1/3 of the supplement, 127.5 divided by 3. Okay, that's 1/3 of the supplement. And then add 10, and that is the angle. So it is true, this angle is 10 more than 1/3 of this. Okay, so that's what we're looking at, is these two together add to 180 degrees. So always go back and double check it and make sure that you can substitute in your supplement or your complement or whatever you got back into what your original angle was and see if that matches. Okay? Linear pairs and vertical angles are probably the most important vocabulary words among the most important vocabulary words that we use all year long. So be sure that you understand how to use those.